Welcome to another video from Dr. Lock. Today this hot little piece of equipment has hit the bench. I don't think it's going to leave the bench in the same type of condition, but let's see what we can do to it. Okay, we might break it, we might mess it up, we might do all sorts of things. Just looking over it, this is one you'd pick up on eBay probably for about 160 bucks. I replaced it. It was getting wet and not working no more. So I replaced it with a better quality one and everybody's happy. The biggest bonus is I got to keep their old batteries. So I'm going to use them, I'm going to do a little bit of testing and we're going to see what's going on with this thing. So I don't think I'm going to be saving it, so I might as well just pull it apart and see what it's made up of. First of all, you can see here's where the keyhole is. There's actually a cap that sits over the top. You use a little magnet and it's got a magnet in the center. You just get that little cap off and then you can use the key. This is one of the rare occasions that I've ever actually had a key. So there's the key, and to use it we should just turn it and we should be able to operate the latch. That's normally how a key works. Isn't that cool? Alright, so that's key override. That's key override. Turn the key quarter of a turn and we're good. Okay, now nothing. From the inside you should be able to turn it and the latch should retract. But from the outside is the control side. Nothing's really happening there. Now this one did go into the water, so I don't know if we're going to be able to get it to make any funny noises or talk to us, but let's just give that a go anyway. Let's put some Duracells in there. Bang, bang, bang. There is a reset button here as well. I'm guessing the default code should be a very simple type of code. There's a little notch here on the connection, so we can only go one way. We now have power to this. Let's test it. Nope, we have nothing working. No keypad, no sounds, no nothing. So what would you do if you're in a lockout situation and you had to do this? Let's find a way in. All these batteries are good. Keypad seems to be stuffed. Do we get an audible tone? No audible tone there at all. Cabling seems to be okay. That seems to be plugged in the back there. Okay, so it looks as if this thing is cooked. Have we plugged it in the wrong way? Is there any possibility? No, because one's higher, one's lower. Pushing it once more and she's cooked. It's not going to be working again. Alright, so now let's pull it apart. And I do this so that you won't have to. Oh, actually, first of all, let's try and get into it. So here's the key here. As you can see, dimples are us on like a happy profile. I did actually manage to find in my... Oh, there it goes. Don't go. I did actually find a pick for it. Now this is a bump pick. So I'm going to try and use that. Happy shape as well, goes into the keyhole. I'm not sure if all the pinning on all the rest is the same, but it looks pretty good, and I've never actually used any of these type of Chinese profiles before, so I'm interested to see if it's gonna work or not. So I've got my bump pick gun here. Just need a good little Allen key now. Here's an Allen key, and here's the battery. Just got it on charge at the moment because I haven't used it for a while. Here's the battery. Let's plug that in. Hopefully we will get some sort of action on this real shortly. Where's that? There it is there. Okay, we've got power. Push the green button. Ooh, we have power. Good power too. Alright, so if I was locked out of this thing and all the electronics have failed me, the customer doesn't carry their key, what am I going to do? Will I get away with bump picking it? Let's find out. Remove that blade, put in the happy dimples are us blade, put in this screw so it's got something to screw onto. Be interesting to, I've never picked one of these dimple ones, so it'll be interesting to see what happens. Alright, so in she goes, applying some sort of pressure. which way does it turn? Okay, so it does turn clockwise. Okay, so I've got clockwise pressure on it. Set. Feather tension. Ah, we got it. See that? We got it. Now we can drive that spindle. It actually did work. Driving the latch, yes. You can see from the front it is in the downwards configuration. So that is the unlocked position, and of course I'm trapping the pins, and I'm probably wrecking the cylinder as well as we speak. Let's just put it back. Looks like it's kind of trapped my my lock picker in there now too. That's not good, is it? Now I've got to try and get it out. Alright, looks like I pretty much just got lucky on that one. So let's go to stage 2. Yes, I got it opened, and knowing what I know now, I probably wouldn't turn it as far. I'd turn it enough and then try and get it out. But picking it wasn't as easy as I would have expected, but nevertheless we picked it. Picking it with the electric pick guns, pretty much just go in there, blow it apart, see what happens, and what happened is what happened. Now we're going to sacrifice this lock for the cause, and we are going to see what's it made of. So here's our wire for the back section. Okay, here's our spindle drive. I'm just going to refocus you there because that way it's not so blurry all the time. Okay, so when you turn this, it turns the spindle a little bit and it's spring loaded, so probably not enough to drive it. Yep, my conclusions are right, not enough to drive it. Push in, we're driving the spindle. So in theory, if you were to smash that cylinder straight through, or something in that cylinder, maybe even a pin or something like that, and push straight through, you should be able to get to where you need to get to that way. There's probably even an easier way of bypassing this mechanism some way. I'm not sure if it's one that you can bump or whatnot, but let's go ahead and see what's actually driving this. Okay, back to this one. Just removing these little screws here. All the screws on the back. Let's take this off and see how what makes this little lock tick. Okay, so here we have a little solenoid. Looks like it pushes when power is applied. Can't really get power out of this thing. Maybe we can, just to see how that moves. Going to take a little stab in the dark here to find out where our negative and positive is. Let's just take it from this side and take it from up, so positive to negative to positive, negative to positive, negative. So it'll probably be that one there. Well, that one and that one will do. Okay, that should give a positive and a negative. See if we can make this little device move. So when power is applied, most likely it will jump. See how we go. Get rid of that. See if we can just quickly touch on this. Wish I had some wire. Here's a bit of wire. There. we go. So that's it kicking out. Let's reverse polarity and see. Okay, so it's kicked out now. See if we can kick it back in. Really should have set up some proper cables for this little experiment. Better than a couple of key rings bent up, but anyway. Getting nothing in reverse, maybe it's probably just not hooked up properly. Anyway, so that's our little push in and push out little drive. What is in this? Is it a motor or is it a solenoid? Let's have a dig. Okay, we have a little motor. Little motor to drive it up, little motor to drive it down. And that was in a spring-loaded configuration doing all the work. So this basically drives this plastic part through a spring, through a central shaft, through a couple of gears, off a little tiny motor. That is what enables the locking function. So this part right here. So I guess when that's pushed down from the outside, we should be able to drive that center, and it's driving it. Okay. So the whole system is relying on just pushing down this one little lug. Could we do that from the outside? No, not really. It's in a metal housing. So there's not a lot we could really do to manipulate it from that direction. But it still is interesting to know that little button there means that you can drive this center part here. Here we go. Some more pieces. So when that pushes down, that enables this center hub. Without that to push down, we can't engage this center hub. So that's what makes it tick. Okay. Now let's look at the front, let's look at the keying part of things. There's a little screw, Phillips head screw down there. Let's see if I can remove that. See if we can get our cylinder out and see what's happening there. Okay, that's out now. Will this center shaft come out? I mean, the actual cylinder should come out for rekeying. There's a little Allen key here on the side for handing to swap it from the left to the right. Let's see how we're going there. And also let's see what the water as far as damage did to it. Okay, so my key is still trapped in there in that funny position. So there's the groove where the handle locks into. The cylinder is built into the shaft, no visible ways to get that out. It looks like it's actually pressed in. I can see a little pin at the back, little pin which might actually retain the cylinder. So I might try see if we can tap that a little bit. See if we can tap that. No, we're getting nowhere with that. That's okay. We have a center cog on the back here. Let's just keep dismantling until we get some action. The cylinders must be able to be removed to be rekeyed. Okay, now this nut right here has a couple of little flaps, little tabs. Push them out of the way, push them out of the way. That prevents it from being rotated backwards. Refocus. Okay, and the nut can come off. Okay, nut comes out. Got any action now? Will that come out? Will the shaft come out? Yes, it will. It will with a bit of force. Okay, so that's our center drive right there. That's of course just a spring. That's our funny little washer that stops it, prevents it from coming off. Another little washer for friction. This plate here is basically to drive the spring. Either side of the spring goes round. As it rotates, it puts pressure on that spring right there, giving it a returning, bouncing feeling. Cool. Okay, another friction washer. Not much there. What do we got down the back there? Looks like we've got some sort of little piece where the screw fitted onto. I would expect the cylinder to be able to be pulled out from the front now, and I would have thought that screw would have been the one holding it in. But there is this pin right here which I'm confused about. So let's see if these are rekeyable. Well, you know, if you had an old one, you just want to swap the thing. I'm guessing they should be in some regard. And I can't seem to get the holder of the screw out. It's just doesn't want to come out. So that's what we're down to at the moment. I'm going to have to get a center punch and see if I can knock that spring out, or see if I can actually knock it downwards and drive the cylinder out. Let's try that. No movement. Okay, so it makes sense that if you want to rekey it, you'd have to knock that pin out, pull that pin out, and remove that screw from the inside. If you could just simply be that little screw, people could slide hammer this out. So that pin there must be holding this cylinder in and giving it its strength. So can we knock it out? Do I have a center punch? I do right here. Over to the bench. Okay, let's give this a little tap and see if we get lucky here. I have to do it side on. Definitely dug in. Didn't do much good. Let's try that again. That pin is not moving anytime soon. Let's try it this way. Okay. That pin is not moving. Just does not want to move. Looks like some sort of sealed unit. Going to get my pick out is going to be a hard job. Alright, let's put that aside. We've been defeated there slightly, temporarily. Let's check out the keypad. Now, keeping in mind that these two wires are the power wires, if they can be breached from the front, that would be very good, because that would give us a way to bypass this by applying some sort of power directly to where it needs to be. So let's see if we can do anything with that. Okay, there's our shell. Here's our keypad. It's all one plastic box. So this is coming from the, so that's the actual drive, and that's coming from the actual battery section. Where's the battery section gone? Here it is here. So in there we've got another circuit board. So there's a few things happening there behind where the power is. For a four pin plug to come to the front to the keypad. Let's see what's in the keypad. Let's see what surprises are here. Now this was getting rained on, so that's not a good thing. We're probably going to see some sort of, oh, there we go. If you can see that, just focus. So the 9 button here, fully corroded, white, black, whiteness around here, little bit of green, little bit of black on the actual buttons. The buttons are just like a silicone sort of thing. Can't really do much with them. I might chop them up and use them for my lotto numbers. This section here, now these little parts right here are LEDs, and these ones here are buttons. So you got your little brass circuitry going one way and little one going the other way. When you push hard on this black section here will make contact between the two elements, and then it will read as a button press. And it's wired up in such a way that when one's pressed, even though they've got connecting wires, you can still tell which actual button has been pressed. Interesting. Okay, so here we have something a little bit more interesting as well. So this is a radio chip, radio crystal. 433 M written on it, so that's megahertz, and that's a little tiny aerial, so that's the UHF frequency band. 434 written on the board, 315 written on the board. Obviously there's two different makes of this depending on which country you come from. So because we're in Australia, we'd be using the 434 or the 433, and other people would be using the 315. Little antenna there, just a bent bit of wire, and that's pushed in. That's probably even soldered on the board, so that's not even reusable. Got a little piezo here, makes a little beep 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 when power is applied, and this is made by Goodum, Goodum, revision 80. Does that mean they've failed 80 times? And CHPHER and EM lock. So that might help somebody if they're trying to find the instructions for this particular lock. Looking at it here, this is like a double-sided circuit board, so everything from the back is not transferred from the front, they're independent. And looking at it here, the circuitry for the power to get to this unit right here looks like it is right here on the front, but you're probably not going to be able to get to that from anywhere. So even if you were to riff off the buttons, it's over to the left, to the right. So if that was there, you would pretty much need to drill a hole right there next to the 9 to access those two terminals and apply power to them and not destroy them. So to get to them through this button, I don't think you could. I mean, you might be able to rip those buttons off even without those buttons on. Looking at that, we need to be down here somewhere. So no easy way there. There might even be a shortcut, just looking at the circuit board. That seems to be one of them there, but there's no holes from the front or anything, so that's reasonably secure. So the overall product doesn't look too bad. One thing I must say is that I think they messed up, is they didn't put any drainage holes in it. So when this was on the door on this slight angle here, all the water just basically came down and got in between here. So a little bit more waterproofing would have probably made all the difference and given this another few more years of life. But unfortunately, it just didn't happen, and the water got through the buttons onto the circuit board, killed the circuit board, and that's what happened. That's the story. As to how I'm going to get this off, I might have to get a hacksaw out to pull that cylinder out to see how they've done it. That pin definitely does look like it's a removable pin, but I don't know. I'll have to give that a real good knock. It's made of just die cast, and I can't seem to knock it out from the from the back, and I'm definitely not going to leave my happy pick in there. Maybe I might get lucky just giving it a yank, but no, hitting a brick wall. Can't force it. I'm surprised we even basically got it with the bump pick gun. Had I've known that, I would have only turned it a slight fraction. Obviously this is one of those locks that has all those voids in it, so you turn it too far or the wrong way and you're stuck and you're trapped. Anyway, that's a strip down of a digital lock. As many pieces as I could bring it into. We didn't do the back, there's just a circuit board and a battery holder in there, but it was still interesting to see how it actually works, that it's all working off this mechanism which is located basically here, and that's actually on the front underneath here. So I mean, if you really is that right? Yeah. If you really wanted to get tricky, I guess a small hole right about here, one small hole just here, through here into the case, and you could push this mechanism. You could push this mechanism because that's its where was it sitting? Where was it sitting? There's the 3 lunks. So it was sitting about here, and it's about there. So once driven, it will be pushed up. Yeah, that's right. That's its highest point. That doesn't seem right at all. Let's flip that around. That's better. That's its highest point, that's its lowest point, and flipping it back over into this section here, I can roughly tell, yeah, Right on the money right there. So, if you do have one of these and they're crapped out and you can't pick it, or you can't get your pick out of it, I reckon a 6mm through there, through this bit of cast, and then through this die cast into this area, fish that down, or go for this little button right here, and you'll be good. And you'll be good. On saying that too, I wouldn't be surprised if you got your vice grips and just crank this around that it wouldn't actually pop open. I've had other ones that have just popped open. I mean, they are locks, but they're not always high security. There's always a quick and an easy way to get into this sort of thing, and when you know it's actually driving it, a couple of little bits of plastic, that you can always find some method of doing it. I think the only steel parts here are in the clutching section, and so it's not a bad idea. It is reasonably spring loaded, so that is interesting. Anyway, okay, just before I go, just in conclusion, I tap this pin in, I tap this pin in, then I put the center punch up the back of it and rotate that out, and it went in quite a way, and there we have it there. So this part right here attaches to the back here, okay, and that basically connects to what does that connect to? That connects to this part here. So that's what is actually driving it. So it's clutching. And then there's my key part there. Don't know why it's jammed, but let's see if we can strip this down a little bit further. So there's one rivet right here holding it in, which I don't know if we'll be able to get that out without drilling. It's a bit late, so I might not be able to drill that. Okay, let's try another method. Key from the back of it. Where's my hammer? Oh, where's my hammer? Have to improvise. Leave no man behind. Can't leave him behind. Might need him one day. Oh, now we're stuck in that way. So as far as getting this actual cylinder apart and gutting it, I might have to leave that for another day. Looks like there's some sort of sidebar happening here on the side as well, and it looks like I can't separate the pins without removing this, without removing that, so I'm going to have to drill and dig that out. Anyway, that's going to be on the next video. I'm going to gut this little thing and see how it's made. Thanks for watching.